I'm really excited about today's episode, okay? Because we are starting to look at data handling. And I just love data handling. But what is data handling? Let's start off straight away by looking at our very first slide. Data is a collection of numerical figures and information used in research. Data handling involves the following processes. So let's have a look at these processes. We got data handling, and with that, we've got to learn that we are going to develop questions. We're going to collect data from those questions we've developed. We're then going to summarize the data. We're going to organize the data and classify it. We're going to interpret the data and analyze all of it. And then we're going to represent that data. So, firstly, this developing questions. Right. So we want to know, how are research questions developed and how are they asked? Have you ever been in a shopping center and somebody walks towards you with a clipboard? And oh my goodness, you know, when someone with a clipboard walks towards you, it's one of two things. Either one, they're going to ask you for money, or two, they're going to say, do you have a few moments? We just want to ask you a few questions. Okay. Not the best time when you're trying to do shopping. So we want to know, first of all, why are questions actually asked to us? Well, sometimes people want to know if there's a need for something specific. So let's say, for example, we've got a shopping center. Okay, I own a shopping center and I have some free space and we want to get another shop into this free space. Well, what shop are we going to put in there? Well, I think we need to know, what are our customers looking for? And the only way we can know what they're looking for is if we go to them and we ask them some questions. Okay, and the type of questions we could ask is, what shop have you just been in today? Do you come to the shopping center often? How many times do you come to the shopping center in a month? Okay, that will help me as the owner of the shop to determine whether or not I need a specific clothing store in that space, or a grocery store in that space, or maybe I need a little restaurant in that space. Okay, so research questions start to develop because we're trying to find out something to solve some sort of a little problem or a question we might have. Let me explain this in a real life situation. Some years ago, I taught at a school, okay, in the Western Cape. And that school was actually very close to a sharp corner. So let me explain it to you on this diagram. Here is the school. Cool? And you used to drive out of the school onto the main road. But the main road had a sharp corner. Okay, so cars used to come along here. Let me draw you where they used to come. Cars would come around here and drive. But the problem was that this road was like quite a busy road, or quite a big road really. So cars used to really get some speed. And some cars would get up to 100, 120 along that road. Now, can you imagine traveling 100 k's an hour, even though the speed limit said 80 kilometers an hour? You know, people don't always listen. They see a long road and they think, cool, let's just put foot. There's no city here, so we're going to go. All right, so cars would travel. Can you imagine a car traveling at 100 k's an hour, going around a corner, and here's another car turning in front of it? That guy's going to have no chance to stop. And so what this school did was they went to the municipality and they said to them, guys, please will you put a robot up? We need a traffic light right here. Okay, let's draw a traffic light. We would love a traffic light there, so that all these cars that are collecting kids late in the afternoon or dropping kids off in the morning, they never have to worry about a car coming flying around the corner. okay, and then there'd be an accident. And so the municipality said, okay, but we've got to do research. We want to make sure that there are enough cars passing that point to warrant a traffic light. And I thought this is a great maths lit exercise, so I took my grade 11 maths lit class and we sat on this corner, right here. We all sat at this very point. And we counted how many cars came past within an hour. So I got all my guys and we sat there from 7 o'clock in the morning till 8 o'clock. Okay, now, during 7 o'clock and 8 o'clock, what do you think happened? I'll tell you what happened. At that time, everybody was arriving to drop their kids off at school. And so we had so many cars coming past, okay? Between 7 o'clock and 8 o'clock, because school started at 7:45, so a lot of cars started coming in just after 7, and they were dropping their kids off, and then they would leave. So we would count how many cars went in, how many cars went out. And we got a huge number, okay? Over 500 cars came in and out within that hour. Yeah. And we took that information, we went to the municipality and we said, see guys, 500 cars in 1 hour. We need a robot. And the municipality says, yeah, sure, you sure need a robot. But I tell you what, we're going to send our people there just to double check your figures. And so that's exactly what they did. They sent people there, but they sent their people there between 11 o'clock and 12 o'clock. Now, how many people drive in and out of a school between 11 o'clock and 12 o'clock? There were less than 10 cars in that hour. So what do you think happened? I'll tell you what happened. We didn't get our robot, okay? Not at all, because according to them, we didn't need, because there weren't that many cars. We both did the same research, but at different times. We chose a time that suited us. The municipality chose a different time. Okay, so research questions develop out of a need. Now, it doesn't really have to be actual research question. It can also be observation. This was an observation. When you go to a shopping center and someone approaches you with a clipboard, that process is going to be with the use of actual questioning. Okay, now, how does one go about collecting data? We've just said that can be by observation, or it can be by actually asking people questions, or it can also be by means of research. Okay, so now organizing data is taking information and arranging it into some kind of order, such as ascending or descending order. Classifying data means organizing it in groups or classes based on some common feature. Let's have a look at an example here. An Audi salesperson has ordered cars from their plant in Germany. The table below shows the number of cars they received. Use this information provided to construct a tally table for cars. Okay, so here we go. We've got some cars. We got the A3 model, we got 2 red, 5 white, 4 silver, 3 black. We got the A4 series, okay? I'm acting like I know what I mean. I have no idea what an A3 is and an A4, okay? It's just like, but let's pretend we know what we're talking about. Okay, so an A4 is a type of car. So we got 3 red, 2 white, 3 silver, 6 black. S3, 4 red, 3 white, 5 silver, 5 black. Q7, I was like, now we're into Qs. Q7, 1 red, 4 white, 4 silver, and 3 black. R8, now we're into Rs. Okay, R8, 2 red, 3 white, 1 silver, and 4 black. Now, we have to put this into a tally table. Right, so this table in front of us is called a tally table. T-A-L-L-Y table. Okay, tally, T-A-L-L-Y table. Cool. Right, so First of all, our color is red. Then we got a white color. Then we got silver. And if you remember correct, we also had black. Now normally for you guys, we would put the tally this side and the frequency over here. Okay. So let's just do that because that's normally the way they do it in matric. All right, so how many red cars did we have? Let's have a look. Our red cars, we had 2, 3, 4, 1, and 2. So let's put that in my tally table. Red, I had 2 of the A3, 3 of the A4, 4 of the S3, 1 of the Q7, and 2 of the R8. If we look at the white, we can see that we actually had 5, 2, 3, 4, and 3. So let's write that in as well. We've got 5 of the A3, 2 of the A4, 3 of the S3, 4 of the Q7, and 3 of the R8. Silver, let's go back and look at silver. Silver, we had 4, 3, 5, 4, 1. Let's put that in our tally table. We've got 4 of the one, 3 of the other, 5 of the or S3, 4 of the Q7, and 1 of the R8. And finally, black, we had 3, 6, 5, 3, and 4. Okay. Now, we're going to find the total. The frequency is the number that we have. So folks, we're just going to add these up now. Hey? That's all we're going to do. 2 plus 3 is 5, plus 4 is 9, 10, 11, 12. Okay, let's use a much nicer color than that. 12, so we can all see it nice and clearly. 5, 7, 10, 14, 17. 4, 7, 12, 16, 17. 3, 9, 14, 18, 21. Cool. This tally table. Now, normally with tally tables, we wouldn't always use numbers. We'd use little dashes, and I'll explain that to you shortly. Let's have a look here. This grouped frequency table shows the heights of seedlings or young plants in different categories. So we've got little seedlings, and we measure the height of them. Now, we've got 3 little plants between 10 and 14 millimeters high. We've got 6 plants between 15 and 19 millimeters high. 7 plants between 20 and 24 millimeters. 5 plants between 25 and 29, and 4 plants between 30 and 34. Okay, so this question now, they've given us the frequency table. I bet they're going to ask us questions about it. Let's have a look at the questions. How many plants were measured all together? All right, so if you look here, all these plants were the ones that were measured. We got 3 of that size, 6 of another size, 7 of, what does that total give you? So if we go ahead now and we add it all up, we're going to get 3, 9, 16, 20, 25 plants in total have been added up. So let's go have a look here, and we can see that we've got 25. How many plants were less than 20 millimeters high? All right, so let's go, what's less than 20? These guys are less than 20. This guy's 20, so it doesn't count because the question is less than 20. Less than 20 are these, which is going to be 3 plus 6, which is 9 plants are less than 20 millimeters. How many plants are more than 24 millimeters high? So more than 24 are going to be these guys. And you can see that there are 5 between 25 and 29, and 4 between 30 and 34, giving us a total of 9 plants. Okay, straightforward, guys. This is really level 1 type questions. There's not much thinking going on here. Now, here's a nice one. What percentage of seedlings are below 25 millimeters? Okay, so how many seeds are below 25? Below 25 are all these guys. Let's use a different color so we can see. All these guys are below 25. So it's 3 and 6 and 7. That's going to give me 9, 16. So there are 16 seedlings below 25. Out of how many seedlings were there in total? Remember, we added them up and we said there were 25. So there were 16 of the 25 are below 25 millimeters. But it says what percentage, and guys, when you hear the word percentage, the first thing that jumps to mind, or the first number that jumps to the mind, is the number 100. Okay? You hear percentage, you think 100. You think 100, you think percentage. Okay? All the time, they link together. So 16 out of 25, we're going to multiply that by 100. Okay? Because we want it as a percentage. Now, we're not going to push percentage on our button, on our calculator, because that percentage is there as a unit. Okay, so the percentage gets carried down, so we can't use it on our calculator because the answer is going to be as a percentage. Okay, so we say 16 over 25 times 100 over 1. Of course, you can do this on your calculator, not a problem at all. 25 goes once, goes here 4 times, and then you multiply that out. 4 times 16 is going to give you 64. So 64% of our seedlings are below 25 millimeters. Right. Next one. How many plants are at least 25 millimeters high? At least 25 millimeters high. We've already answered that. There are 9 of them. Okay, we got to move along because our time's going quite quickly. Let's have a look here. In the exam, you're required to show results in terms of 7 performance levels rather than percentages. Remember, we've got level 1, level 2, level 3, level 4, level 5, level 6, level 7. Level 1 is the outright failure, hey, below 30%. Level 2 is in the 30s, level 3 in the 40s, level 4 in the 50s, level 5 in the 60s, level 6 in the 70s, level 8, just like how cool is that, in the 80s. And right, so let's go for it. All right, so as a result, the subject internal moderator who is analyzing the results needs to work out the number of learners per performance level. Complete the frequency table to work out the number of learners per performance. So there we have it. Okay, levels 1 all the way to level 7, with level 7 being 80 and above. Right, now we're going to look at that the marks, and then we're going to see how many there actually are. We're not going to do all of them because there are a lot of marks, and I just want to teach you the basic method of it. Okay, so we have a 54, and 54 we know fits into the 50s. So I'm going to say, you know what? There's 1. Okay, then I'm going to do this. We've got 67, 83, a 67, and a 83. Right, then we've got done those, a 34, 49, 50. So we got in the 30s, 40s, 50s. The 30s, the 40s, and the 50s. So I'm just putting little strokes down to represent every one that I have. Okay, again, we got 70, 80, 90. 70, 80, 90. We got a 70, we got an 80, we got a 90. Then we've got, I'm not doing very many of these, a 70, 20, 40, a 70, 20, 40, a 70, a 20, and a 40. All right. And then we've got a 50, 70, 80, a 50, 70, 80. Oops. Let's get down there. 50, 70, 80, a 50, a 70, and another 80. I'm just going to do one more quickly. A 50, a 20, a 40, a 50, a 20, a 40, a 50, a 20, and a 40. Right. And let's take these three quickly. Okay. A 90, a 80, a 29. A 90. Okay. Now, I've done this because I've jumped to the 90 because I want to show you something. On the fifth one, people, I'm not going to put a little line. I'm going to do this, cross those four out. So every time I see one of these things, I know that represents 5. So if I had another 5, I would do that. So now it's easy to count. Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I can just say that's 5, 10. So much easier to count. If this were the end, it's not. I haven't done all the information, so I'm just showing you. Now, time is up. We need to take an ad break, but let me just show you quickly. If this were all the information, which it's not, I would say, right, 1, 2, I got 2 here. 1, I got 1. 1, 2, 3 here. 1, 2, 3, 4. 1, 1, 2, 3, 5, 10. Straight away. Okay, that is a real wonderful frequency table. Right, let's conclude this for today. In this segment, we've covered the following. We have introduced the concept of data handling, and we've drawn up and worked with frequency tables. Folk, I'll see you after this break.